Today's subject will be HIC, History of Industrialization and Construction, and in particular 6 examples. And 3 of these examples will be housing, and 3 of these examples will be university buildings. So basically, we have 3 types of systems. One would be a modular system. Everybody knows this. It's a container-like element. Could be columns in the angles instead of walls, and you can stack them up. So you would have the double floor each time. So these are modules. Second would be skeleton. So in a skeleton system, you could have columns over several stories, could be 1 story as well. And then you would have a primary structure, and maybe a secondary structure. So this is skeleton system. And the third system that has been used frequently was a wall system or slab system, where you would have slabs with openings or without openings, and floor slabs may be divided in 2, but this is a slab-based system. So why did I choose housing and universities? After the Second World War in Germany, you had a big default of housing, and some people say there were about 6 million units missing, and you had occupation of existing residential spaces by force, so people were put in your house, coming from the eastern territories that then belonged to Poland or Russia. And there had been destructions during the wartime as well. So these were the main factors. And after the war, the housing industry was working up to its limits, using more or less conventional techniques which were brick and reinforced in situ concrete constructions. So these were not sufficient anymore to cover the need of houses after the Second World War. And this is why industrialized methods came to the front and were used more frequently in those years. So one of the big size slab systems would be the buildings by Ernst Giesel, Swiss architects, in Märkisches Viertel in Berlin. Märkisches Viertel was quite famous at the time, because people were killing themselves because they had to live in Märkisches Viertel, so there was a big polemic in Germany about whether this was human or not, well, whatever. And the big slab construction systems were based on a French system named Camus, developed in the 50s and mostly commercialized in the 60s. And the Camus system was a system of floor slabs and walls and rebars sticking out, and then you were pouring in situ concrete in the cavities and thus linking all the rebars sticking out of the elements. So basically that was this, and the facade was composed out of 2 slabs, outer slab, inner slab, and an insulation in between. Insulation was about 4 to 6 centimeters, so not what we are used to today, but at the time this was at least insulated, which was for a concrete building not so bad. Can you see this? Maybe not. So here, some more in situ concrete, and the next element on top of this one, and a sort of overlapping scheme for the outer layer of the facade. So the advantage of this is that you are using wall panels as a structure which are necessary as interior subdivisions anyway. But the disadvantage is that you had a lot of walls and not a lot of flexibility. So as we will see later on in university construction, flexibility was a topic at the time as well. And well, this system here, big settlements have been erected using this, especially in communist or socialist countries, because this could be produced in large series in factories, and as these economies are based on a planified approach, this could be planified easily, and demand was very controllable. People didn't have enough apartments, so they were happy with what they got. And so a lot of these buildings in, for example, former East Germany, that were easily occupied because everybody was looking for apartments as well. So this big slab system was used in most cases to create a lot of apartments. Like in 1972, 720,000 units were built. Today in Germany we are building around 300,000 units, so that was more than double, which shows that there had been some success at the time to produce square meters. In 1972 there was a different approach in Munich done by Steidler architects. And Steidler architects, they were using construction system for industry with prefab concrete columns and little consoles. And then on these consoles they had primary beams, and on the primary beams were sitting secondary structures. So with these three elements, the columns, the primary beams that could do a cantilever, and the secondary structure, they were able to create a sort of shelf, and then on the shelf they have been adding infill elements built out of aluminum. So you had a sharp contrast between reinforced concrete and the aluminum infill. So it became very clear that here we had a skeletal structure, and the building envelope was solved in another material. Disadvantage of this approach was a lot of thermal bridges. In 1970 this was not this problematic yet, but it's a major advantage of this type of approach. Third example I'd like to show you is an example by Richard Dipl. Richard Dipl was conceiving a world urban system, and this was a system based on the principle of Vier en Deel trusses. So Vier en Deel truss is a truss with rigid angles. So as you turn the angles rigid, it doesn't bend as much as it would without these rigidifications. And Richard Dipl, he has been cutting this even further by reducing it into square-like elements. And then he introduced the same in the other direction. So he received some sort of cube, and the cube was once again divided in the middle, and so he obtained angles. And these angles then were assembled to form the square. And this way he could use always the same element. But disadvantage, he had a lot of screws. And as these elements were out of metal, they had to be produced individually. And you had a lot of rather complicated individual elements, but they were rather repetitive. So with this system, I told you about the Vier en Deel trusses, he could build giant structures over streets, so all this composed of the individual elements. This would function as a big truss over the highway. And you could have cranes on top of it delivering new modules. So all this was a solution for all the housing problems in the world. And finally, he was offered the opportunity to buy one of these units in Wulfen, which is in North Rhine-Westphalia in Germany. And he jumped on the occasion, built the thing, and well, it was rather complicated, as you can see on the construction drawing here on the side. But then after 16 years it was demolished. It was demolished because there was little maintenance, and there were some thermal bridges as well, and people didn't really want to live in this. And at the construction it had been 20% more costly than comparable housing projects were. So in fact, a couple of disadvantages, and you can see that the idea of mass producing the same elements is not sufficient to guarantee low prices as an outcome. So another sector which was very much covered by building systems is university construction. Why was this so? When I went to school, there was about 5 to 10% of 1 year getting a high school degree in Germany. And today it's about 55%. So we have something which is called academization over here. It means that more people should have access to higher education. And this started out in the 50s and 60s. There was the Sputnik shock. Maybe you remember Yuri Gagarin flying in space, and then the Americans and the Germans were thinking that the educational system was not up to date anymore, because John Glenn was 1 or 2 years later than Gagarin in space. So as to be able to compete with the communist systems, we should build more universities and all of this quickly. And there was also Pillenknick, due to the invention of the anti-baby pill. There was less natality, and so the few people left over should be educated in a better way. As the concrete need was not visible at the beginning yet, planners were thinking very much about flexible structures. So in fact, building square meters and then being able to occupy them in one way or the other later on. So much of this university construction was done in prefabricated elements, and in many cases the program was defined afterwards or during construction. So the first example that I'm going to show you is done or was done by a rather famous architect by German standards, Günther Wenisch, and his office. And it concerns the University of Applied Sciences in Ulm. So Günther Wenisch won a competition with his office, and at the time he was having more and more problems getting his projects built in a convenient way, because the building industry was completely overcharged and couldn't produce the quality that he was asking for. So he designed a very nice building layout of different rectangular volumes and courtyards and whatsoever I'm inventing here. And then after having won the competition, he developed a system to build this. So the system was rather simple. It was basically columns and beams and floor slabs and facade elements with rectangular openings in them. So nothing very fancy. And the whole thing got built in this system and was a huge success, because this rather strict realization gave an additional aspect So this not free form, but rather well-composed ensemble. And the combination of these two was rather successful, as you can see. Building exists today. A lot of joints. At the time there was a dictum in Germany, ist dir beim Detail nicht wohl, nimm Thiokol. So also the salons to treat all these joints from the outside have been developed during this area, and that was necessary to work in a large scale in prefabricated concrete elements. So another well-known example of German university construction is the Lahnberge development in Marburg. And here architect Helmut Spieker, as director of the planning office, developed a system which is based on a square basic unit. So the whole thing is a sort of cancerous development, and this is subdivided in a square way. And then the basic unit is 4 columns, and the particularity is that the structure traverses these 4 columns here. So it could be interpreted as a table as well, but it's not. It's only a continuation of the primary structure. Here, another columns. And then you have secondary and tertiary structures, but all of this is very much adapted to the square grid. And another particularity is that the envelope is situated in this position. So if you look at it from the outside, you see these columns here and the load-bearing structure of the floor slabs exposed on the outside. And here this is a balcony, a fire escape, which contributes largely to the exterior expression of this building. So this is rather based on a square unit, which is then multiplied as much as you need it. You could add this or this to it, or have a square in the middle, or whatsoever. So it's very much based on a basic unit, which is then produced in large series. Our third example of German university construction is situated in Kaiserslautern. And here, as the university was built largely in the 60s and 70s, they constructed a building complex without knowing how it would be occupied finally. So they had 2 building types, one rather flat and one-story space, and in front of this a couple of administrative and laboratory buildings. And these buildings here were produced in a series, and they are rather simple in structure, core, and also a square grid, but not as universal as in the case of Marburg, but rather something which could be inhabited in a rather pragmatic way. Basic structure, and then these columns here had consoles on either side. And on the consoles you had primary beams, and on the primary beams prefabricated concrete elements of this shape, and then parapets made out of insulated concrete. So that's the basic building structure, and they simply produced square meters without having a particular shape in mind. A rather pragmatic idea. Buildings are not so bad with band windows. Yes, so now you have seen 3 different ways to approach the problem. Either to start with a project and then try to materialize it. Second, to develop a sort of universal system. where the system itself becomes more important than what you put into it. And the third, to erect rather typical buildings which offer the possibilities to house all type of institutions, from maybe a building construction chair to a chemistry department. So the danger is a little bit that once you have developed the ideal system, then the problem of architecture is solved one time for all. Is this the sense of industrialized building? The question has still to be asked.